Alright, we're going to just work on our problems that are on the back. First, we're going to start with segment addition postulates. So M is between L and N. We notice M is between those 2 points, but we don't have any proof that there's congruency going on. They said L to M is x plus 4, so I'm going to label that. M to N is 2x, so I'm going to label that as well. Okay? And then L to N I know is the whole distance here, which is going to be 25. One thing that we need to understand with segment addition postulate is I can take one part of my line, I can add it to another part of my line, and when I add those 2 parts together, it's going to equal the whole distance. Okay, so we know that x plus 4 is the little part, 2x is another little part, and then 25 is representing the whole thing. So let's set that up. X plus 4 plus 2x is equal to 25. Now let's solve for x. X and 2x combine to make 3x. I leave the plus 4. Then I want to move the 4 to the other side by subtracting. And I'll get 3x is equal to 21. And then my last step is to divide by 3. So I'll get x is equal to 7. Okay, big thing. Part plus part equals whole, but our parts are not congruent to each other on this. Okay, alright, so if we're going to look at the next problem, F is between E and G, so if I don't have that, I want to draw it. Well, E and G and F is in between. Does not need to be exactly in the middle, it's just somewhere in between. So I know that E to F is 3x plus 5. I know that F to G is 2x minus 3, so I'm going to label that. And then E to G, which is the whole thing, is 27. So now I know my 2 parts, and I know which one's the whole thing. I'm going to set up my equation. I'm going to take one part, which is 3x plus 5, add it to my 2x minus 3, and set it equal to 27. I'm going to combine my like terms, so 3x and 2x make 5x, and then the 5 and the negative 3 will combine to make 2. Now I'm going to subtract the 2 from the other side to get 5x is equal to 25. And then my last step is to divide by 5 on both sides. And I'm going to get x is equal to 5. This question is asking us to find EF, so I know specifically if I want to solve for just EF, I'm going to plug it into the segment that is represented as EF. Well, it's 3x plus 5. So instead of 3 times x, I'm going to do 3 times the value I just found, which is 5. 3 times 5 plus 5 is going to give me a total distance of EF equaling 20. Okay, so there we found what x is. We just need to plug the value of x back in and solve for the missing piece. Okay. Alright, so if we have a segment bisector, now we have proof. These are called congruent tick marks, but we can still do the same philosophy where I have this part, but I know that my other part is going to be congruent. It's equal. So we have parts is the same thing, part plus part equals whole, except our parts this time are going to be congruent. Okay? Even if I'm not adding my 2 parts together, I know they're congruent, so if they're different, like these 2 parts, they're different, I know I can set them equal to each other since they are the same. So let's do that. Set them equal. 5x minus 7 is equal to 14 minus 2x. I'm going to do 2 steps in one by adding 2x, so that cancels out my negative 2x. And then I'm going to add my 7, and it cancels out my negative 7. So I can go down. 5 plus 2x is going to give me 7x. 14 plus 7 is going to give me 21. And then I just divide by 7 on both sides to get x is equal to 3. Now this one asks us to find the length of PM, so P to M is the 5x minus 7. So instead of 5 times x, I'm going to do 5 times 3 minus 7. That's going to give me a total distance of 8 for the length of PM. So again, solve for the value, we just plug it back in. This one, we have parts, plus part equals whole, but there I don't have a whole. So if I don't have the whole distance, I know that these 2 parts are equal, so we set them equal to each other and we solved. Alright, line QP bisects segment AB at point C, so let's draw that. I know I have Q to P, and line QP, I got this backwards. I have AB that is being bisected by line QP. So QP is going in the middle of AB. Where is it doing it at? Specifically at point C. So segment AB is being bisected by line Q. So A to B is being bisected in the middle. When it's being bisected, I know that my two pieces are congruent. Right? I can do the same thing that we just talked about. I can either set those two equal. If I can't do that, or if I have the whole, then I just add part plus part equals whole. Well, here A to C is 9x plus 18, and then C to B is 12x minus 21. So I have this section and this section, so I do not have the whole. So I know that I need to set these equal to each other since they are congruent to each other. So I'm going to do 9x plus 18 equal to 12x minus 21. And here I'm going to do two steps in one again. I'm going to subtract 9x from both sides, and I can add the 21 to the other side. Therefore my 9x cancels out, and my negative 21 cancels out. 18 plus 21 is going to get me 39, and then 12x minus 9x is going to get me 3x, and then I just divide by 3 on both sides to give me x is equal to 13. I want to plug it back in and find the length of AB. Well, I don't have the length of AB, but I do know that these two pieces are congruent, so when I find one of them, it's going to be the same distance as the other. And then I can add them together to find the total between the two. So it doesn't matter which one I'm going to plug it into. I'm going to plug it into 9x plus 18. So instead of 9 times x, I'm going to do 9 times 13 plus 18. And it's going to give me a total of 135. Well, I know that this little section from A to C is 135. That means the other section from C to B is also 135. So I'm going to add them together to get a total of 270 between A to B. Alright, with that same philosophy, with a bisector, midpoint is the proof that I have that there's a point in the middle, and I can say my two pieces are congruent. Now I can either see tick marks, right? These are two tick marks that match up to 2. I can have 1 that matches up to 1, 2 that matches up to 2, or 3. I can keep going with my numbers. But if I have a midpoint, I know that these two segments are going to be congruent. So here, I know that these are my two segments. I know they're congruent, so I'm just going to set them equal to each other and solve. I just need to add 10 to both sides here to get 4x is equal to 88. I'm going to divide by 4, and I'm going to get x is equal to 22. So that one was a lot easier. All we need to do is just solve for the value of x. But if I did ask you, what is the length of Q to T, you don't even have to plug x back in. I know that T to R is 78, so that's going to be the same distance as Q to T. So if I did it correctly, I could double check by plugging 22 in the spot of x. 4 times 22 minus 10 should get me 78. Alright, another one that's just like that. B is the midpoint of A to C, so I'm going to draw A to C, and B is exactly in the middle. With us seeing the proof of the word midpoint, I know that my two pieces are congruent to each other. Well, A to B is x plus 6, and then A to C is 5x minus 15. Well, I have a part, I have the whole, but I don't have the other part. But since I know from reading my question and seeing that it's a midpoint and knowing that my two sections are congruent, I don't need the other part. Whatever the other part is, it's the same. So I've got x plus 6, and the other part is also x plus 6. Now I can do part x plus 6 plus my other part x plus 6, and it's equal to the total 5x minus 15. Now I'll just solve for x. I get 2x plus 12 after combining. And then I'm going to do two steps in one. I'm going to subtract 2x from both sides, and I'm going to add 15 to the other. That's going to give me 27 is equal to 3x, and then I divide by 3 to get x is equal to 9. Now this one asks me to solve for the value of A to C, which I know is the total distance, so I can plug 9 into this equation. So 5 times 9 minus 15 should get us a total distance of 30 for the length of A to C. So again, solve for x, plug it back in. Alright, I now want to find a midpoint on a coordinate plane, and I don't even need to use a coordinate plane. My formula is adding my two x values together, dividing by 2, and then adding my two y values together and dividing by 2. If it helps, label underneath your values. I have an xy for a first coordinate pair, and I have an xy for a second coordinate pair. So x1 is 6 plus x2, which is -2, and then I'm going to divide by 2, and that's going to get me a total of 2. Okay, so I know my x value for my midpoint is 2, so I'm going to go ahead and start my equation. And then I do the same thing for my y's. y1, which is -4, plus y2, which is -6, divide by 2. -4 plus -6 is going to get me -10. Half of -10 is -5, so I have a midpoint that's at 2, -5. Alright, so just add the x's together, divide by 2, just add the y's together, and then divide by 2. Now if I have a line segment and I have an endpoint and I have a midpoint, I need to find the other endpoints. Alright, so what I like to do is I don't need to do any math at all. I'm just going to put dots on my graph. I know Q is at 6, -4, so I'm going to go 6 down to -4, and I can label it Q. And then I'm going to label M at 5, -1. I know it's a little tiny, it's hard to see, but just correctly put them in the correct spots. I need to go from the endpoint to the midpoint, and then I need to go from the midpoint to the other endpoint that I'm missing. So all I need to do is count my movements. From Q to M, I would go 1 to the left, so I'm going to mark that down. And then I would go 1, 2, 3 up. So from the endpoint to my midpoint, I went 1 to the left and 3 up. So to go from my midpoint to the endpoint, I'm going to do it again. 1 to the left, 1, 2, 3 up. I'm going to put a dot, and I'm going to label it R. Now we can notice that R is located at 4, 2, and that's my answer for the other endpoint. Last one, distance formula. Now there's two ways you can go about this. You can either draw on your coordinate plane a Pythagorean theorem right triangle and do a squared plus b squared equals c squared. You will see that in your recap on your worksheet in Canvas. Or you can just plug everything into your distance formula. You just need to be careful that you're plugging everything in correctly as you see negatives and positives. I'm going to label my values x1 and y1, and then x2 and y2. Now my distance formula, I just take everything and plug it in. Make sure that when you have a negative number, such I see as -3, I want to make sure I put parentheses around my -3, as well as I'm including parentheses where it's appropriate in my formula. So x sub 2 is 1, so I'm going to do parentheses 1 and then minus x sub 1. I'm going to do parentheses -3 since x sub 1 is at -3. I need to close my parentheses from the left side and then square it, and then do plus y sub 2 minus y sub 1. So that's 5 minus my other one, which is 2. Make sure that there's parentheses around this as well, because if this number comes out to be a negative number and you square it, your calculator will input that incorrectly. So you need to make sure you are putting it into the calculator correctly. So I'm going to grab my calculator and I'm literally going to plug in exactly as I see it. So you can see that I've already done it right up here. I have it matching exactly the same that I have. So I know that it doesn't look exactly the same. I'm lying on top of that. I don't want to be a liar. But right here, before I did it, I put parentheses around this -3. Okay? And when I click enter, they will go away. But you want to make sure that you include those parentheses right there in that spot. Notice how once I entered it in, they went away. But I need to make sure that I'm including them. So our answer for the total distance is 5. Alright, let's do our next one. I'm going to do the same thing. I'm going to label x1, y1, x2, y2. Take my formula and plug everything in. So I take the square roots of x sub 2, which is 3, minus x sub 1, which is 5, and then I square it, plus y sub 2, which is 7, and then y sub 1, which is -1. So I'm going to do minus parentheses my -1, close it, and then add my square. Exactly plug that into the calculator is exactly as you see it. If you don't know how to find the square root button, you hit Control and then my x squared button, and you will trigger this little yellow button right above it. When we get our answer, we will get 8.24621, and we want to round to the nearest hundredth, so 2 decimals at 8.25.